let's continue. So same thing, this is more than or equal to 0, so it is not non-positive series. So yeah, but here we have this P, and this P here should be a real number. Okay, so we need to find for all P whether this sum converges or diverges. Okay, so let's say, let's split into two cases. Okay, so if P is less than 0, then what happens? If P is less than 0, then what test should we use? Can we use limit test? And actually the answer is yes, because if we use limit test, we'll see that limit n tends to infinity of 1 over ln n power p. If p is less than 0, this will be limit n tends to infinity of ln n power minus p, and this minus p will be more than 0. So as n tends to infinity, this will tends to infinity, right? So by limit test, the sum diverges. Okay. Then what will happen if p is equal to 0? If p is equal to 0, then the sum becomes the sum of 1. The sum of 1. And this diverges. You can use limit test also, because the limit n tends to infinity of 1 is 1, not equal to 0. Okay. Next, if p is more than 0, then okay, this will be more difficult, because it will be 1 over ln n power a positive number. Can we use limit test? No, because if p is more than 0, if we apply limit test, if p is more than 0, then limit 1 over ln n power p as n tends to infinity will be 0, and there will be no conclusion, right? So we cannot use limit test for p is more than 0. Integral test, I will skip. Okay. Comparison test. Maybe we can use comparison test, and maybe we can also use limit comparison test. Let's just use limit comparison test. Okay. We will compare this with 1 over n. Okay, so for for p is more than 0, let an be 1 over n and bn be 1 over ln n power p. Okay, then the limit n tends to infinity of an over bn is equal to limit n tends to infinity of ln n power p divided by n. Looks like we can apply Hospital rule because this is infinity over infinity if p is positive. So let's make it in, let's change the n to x. Okay, and I will make this substitution. So I let x to be e to the power of y. Okay. To make it easier to do Hospital rule. So it becomes y tends to, as x tends to infinity, y will tends to infinity. And I will have y power p divided by e to the power of y. Okay. Why I change it into this? Because if I apply Hospital rule, the below will remain e to the power of y. So we only need to care about the above, right? So let's say we do Hospital rule once. I will get p times e to y p power p minus 1 divided by e to the power of y. If we do Hospital rule twice, I will get y tends to infinity of p times p minus 1 y power p minus 2 divided by e power of y. And I can keep doing this. Okay, and I will have p times p minus 1 times p minus 2 and so on until what? Until 1 y power 0 divided by e to the power of y. Is this correct? Is this correct? If I keep doing Hospital rule, I will get this. But this is not true. This will be true if p is integer, right? But p may not be an integer. So after I apply Hospital rule, I may not get 0. Okay, so for example, if p is 2.2, so I will have limit y power 2.2 divided by e to the power of y. Apply Hospital rule once. Then apply Hospital rule twice. And you see, if we apply Hospital rule again, this will not be 0, right? But how to solve this? We can just apply Hospital rule another time, right? Now we get 1.2 times 0.2 y power of minus 0.8 divided by e to the power of y, and this will be 0, right? So for this particular example, we know that we can use the same trick, but we just need to change this and this. Okay, so after doing Hospital rule, floor p times. Okay, after doing Hospital rule, floor p times. After floor p times. Okay, for this case, you see, after doing twice, which is floor of this. Okay, I will get this expression. So after doing floor p times, I will get this will be p minus floor of p, right? Here will be p minus p. P minus floor p minus 1 times y to the power of p minus floor p, right? Okay, and we see that if p is not integer, this will be sort of like 0 point something, and we do orbital rule one more time. Okay, so we can say that if p is integer, okay, then p minus floor p will be 0, and limit n tends to infinity of an over bn will be limit y tends to infinity of p factorial divided by e to the power of y, and this will be 0. If p is not integer, then but positive, okay, it's not integer, where p is more than 0, then p minus floor of p will be more than 0. So limit n tends to infinity of an over bn will be this expression, limit y tends to infinity of p times p minus 1, and so on until p minus floor p minus 1 dy p minus floor p e to the power of y, and we can apply Hospital rule again. So we get p minus 1, and so on, p minus floor p minus 1, p minus floor p, y power p minus floor p minus 1 divided by e to the power of y, and this will be less than 0. Okay, so this limit is equal to 0. Okay, so for all cases, okay, if p is more than 0, no matter whether it is an integer or not integer, we have that the limit of an over bn is equal to 0. So what does it mean? Okay, let me copy here. Limit comparison test. Okay, it's okay. Smaller. Okay, so we have L here, which is limit n tends to infinity of an over bn is equal to 0. And we also have our an which is this. Okay, that the sum of an diverges. So we can conclude that the sum of bn diverges. So by limit comparison test, the sum 1 over ln n power p, and it starts from 2, right? Yes, and starts from 2 to infinity diverges. Okay, this result, okay, this result is actually the result from the question 4 in this tutorial. Okay, so to conclude, no matter what is the value of p, you will get that the series diverges. Okay, so for all values of p, hence for all p, this diverges. Okay, done.